Hello, everybody. Welcome back for a new episode of the Midnight Sessions. Just wanted to confirm for those that are present. John, can you hear me? We had an issue last time that people were were uh, were not able to hear me. Uh, who is else present? Andrew, can you guys hear me? All good. Perfect. Okay, just wanted to make sure. Okay, so today is going to be packed with a lot of really nice information regarding the ecosystem. We're going to go through some coding, and then I'm going to open the mics for anybody that has any questions. Regarding the questions, you can write your questions on the chat, or if you just want to jump into the stage, you just raise your hands at the end, and I will invite you guys. Okay, so let's start exploring what we have for the ecosystem. We're going to analyze two blogs. One, it's the Midnight at Money, which was in Amsterdam. And then we're going to go through a summary regarding tokenomics. And then we will keep exploring other things. So let's start with the blogs. I made a summary regarding this blog at the Midnight at Money 2020. The topic that was discussed and something that Midnight really pushes is the concept of rational privacy. So what is that? Let's read. Rational privacy, it's customizable. It uses programmable privacy and selective disclosure to allow firms to verify data without revealing the data publicly, creating a system built for real-world financial operations. CK proofs are powerful privacy tools, but can be technically challenging to implement. This difficulty has historically been a significant barrier to their adoption. A key part of Midnight's strategy is to solve this developer experience problem. So there's two topics. One, it's regarding rational privacy, and Midnight is going to allow us to do that. And the second point, important, is regarding developer experience problem. Doing these circuits and actually implement it, it's real hard. And with the Midnight SDK, we actually are able to implement end-to-end applications without actually knowing anything about cryptography. We just use APIs. Midnight uses Compact, a domain-specific language based on TypeScript, which is a language familiar to millions of developers. Compact abstracts away much of the underlying cryptographic complexity. So we are analyzing on these sessions this Compact language, which is a DSL, and it's really easy to actually write circuits. We just need it kind of looks like TypeScript. The future of blockchain with Midnight is thriving multi-chain ecosystem, where different networks with specialized strengths complement each other. With this in mind, Midnight is designed for interoperability. We're gonna see a tweet later on that actually discusses this topic, which is kind of being Midnight, the tissue that's going to integrate different blockchains. This means Midnight will be designed to enable a privacy layer for dApps on other blockchains. A development team could build its core application on any network and integrate Midnight's technology specifically for privacy-enhancing features. The benefits of a public blockchain can be enhanced with privacy where it's expected by users or required by regulators. So that's something really powerful because we can actually start using blockchains as servers, like in the Web 2 world, where you have your main server and then you can call other services as APIs, and the user, they don't need to know what are the servers they are talking to. They just talk to your server, and you are responsible to talk with the others. In blockchain, it was really difficult to do because of the tokenomics at the tokens. The user need to have those tokens specifically. But now, with this integration, we're going to be able to actually blockchains use other blockchains as services without the user knowing about it. So now let's take a look at this blog, which was a summary regarding the tokenomics and really connects these concepts that we just took a look. So let's open this blog. It's really short, so we're gonna go through these. Let's zoom out this. So there is key concepts, and here Fahmi Sayed, who is the president of Midnight Foundation, he made a really nice summary regarding the white paper. So let's take a look here. The Night. What is Night? It's a utility token. It's going to be a token that's going to have a supply of 24 billion tokens. It powers generation of dust, the capacity resource, and fuels participation incentives. Some key properties. Resource generation. Holding Night will generate dust, the midnight network capacity resource used to power transactions and smart contract execution. Block production rewards. Night will be distributed as a reward to incentivize block production via a protocol managed token reserve. Decentralized governance. So Midnight's going to have a governance as well. Over time, Night will enable holders to take part in decentralized on-chain governance, helping to shape the protocol's future. And ecosystem incentives. It is expected that a Night on-chain treasury will be used to fund Midnight ecosystem growth. Okay, what about Dust? Dust is the shielded resource that powers transactions on Midnight. It is perpetually generated by holding Night, allowing users and developers to plan network usage without guessing at future cost or spending utility token. This is really powerful regarding businesses' applications, because normally a business, they need to forecast their spendings in the following 2 years, and having a volatile token, it's really hard to do, right? So you actually need to have a native token that you can forecast your costs. So with Night generating Dust, you're going to be able to do that. The white paper covers the role of Dust, its relationship with Night. So what is Night doing actually? Dust generation and capacity, Dust designation and transaction enablement, and Dust decay. So this Dust decay, it's actually what makes all this connection with Night and Dust possible. You're gonna be holding Dust on a wallet. You're not gonna be able to transfer it, and it's gonna decay. So if you don't expend it in a specific amount of time, it's just gonna decay. It's gonna go to zero. This concept is really powerful. Cooperative tokenomics. Let's see what it's about. Midnight's cooperative tokenomics model is designed to enable multi-chain architecture and to allow the network to become a truly interoperable layer that evolves as a connecting tissue across different networks. The white paper envisions mechanisms for expanding network access and enabling a multi-chain Web3 future. There is 3 really nice concepts. The concept of a capacity marketplace to expand network access. Potential capacity marketplaces models, both off-chain and on-chain, and how these marketplaces could enhance the on-chain treasury. This part is going to make sense later on, because in Midnight there's going to be a treasury, but since when you execute a transaction, you don't spend Night, you actually spend Dust. How the treasury is going to fund itself in the future. So these capacity marketplaces, it's going to enable some means for the treasury to actually fund itself. Incentives. Block production rewards. The Midnight network will leverage Cardano's robust proof-of-stake system for consensus as security. The tokenomics and incentives system is designed to achieve sustainable and predictable network operations. The white paper covers the block producers, block production rewards, and calculated rewards. The tokenomics, it's actually how to express this. I was really impressed. I was really happy about the tokenomics. They are airdropping 100% of the tokens, and those that comes after the glacier drop is going to be divided between the stakeholders, and one of the stakeholders is the treasury and the reserves. The Night token distribution. So the paper introduces a Night token distribution framework called Glacier Drop. the free multi-phase distribution mechanism designed to bootstrap a broad and diverse community around Midnight. The token distribution will shape the network's future, and the goal is to build an ecosystem that's resilient, diverse, and fair. 3 distinct claims phases, starting the glacier drop, eligibility and mechanisms of each phase. Actually, the snapshot was already taken, and later on we're going to be able to request those tokens and then claim those tokens during a 1-year period. Key milestones and expected timelines of the distribution. So key topics regarding the white paper, it's Night utility, Dust utility, cooperative tokenomics, with the concept of capacity marketplace. This concept here is going to be really huge in the future, capacity marketplace. Okay, so now let's take a look at the tweet that Charles did regarding a post of Sebastian. Sebastian made this post. With Midnight launch coming, we are working hard to bring hybrid apps that combines multiple chains at once. Remember that we were discussing these tissue mechanisms, how different blockchains are going to be able to connect to each other through Midnight. Here's our work in progress explorer, so you can easily see how your state machine is updating from data across multiple chains. And Charles comment on that tweet saying, this is one of the most important work streams in the entire industry, alongside dual token model and capacity exchange. So 3 huge concepts: dual token model, Night and Dust, capacity exchange, and hybrid apps. Actually, how this tissue is going to work. Okay, now let's study some of the diaries of Midnight. This time we're going to study the switching from one proving system to another, which was the Pluto's Aries elliptic curve to the BLS elliptic curve. And let's study why Midnight decided to switch between these curves. So let's open this diary, and we can see here a table comparing these two families. One is the Pluto's Aries and the other one is the BLS. First, the trusted setup. They talk about cryptography, transaction time, transaction size, transaction verification time, complexity, maintainability, and cost of recursive step. So we can see here that the transaction time with the BLS family, which is the actual elliptic curve that Midnight is using, it's faster than the Pluto's Aries curve. The transaction size is smaller, 5 kilobits per proof. Transaction verification time, it's much shorter as well, 6 milliseconds per proof, and the complexity it's lower. So let's take a read here. Moving away from trusted setup ceremony. One of the most compelling reasons to adopt BLS family in its use of an existing standardized trusted setup. Pluto's Aries, by contrast, requires a bespoke ceremony. So it needs ceremony, and BLS, it already has a standard ceremony. In embracing a standardized cryptography, Pluto's Aries relies on standard cryptography, which, while innovative, poses risk in terms of interoperability and long-term support. BLS, however, is built on standard cryptographic primitives that are well understood, extensively tested, and broadly adopted. By adopted, they mean we know that Cardano now accepts BLS curves. We have Identus, they accept that curve as well. The majority of CK systems, they adopt this BLS family as well. So you're going to have interoperability with between these systems. Bootstrapping transaction performance. Performance is a critical factor in any cryptographic system, and BLS outshines Pluto's Aries across several key metrics. Transactions are faster, verification times slash from 12 milliseconds per proof to Pluto's Eric's to just 6 milliseconds. That's half of the time. Additionally, transaction sizes are more compact, dropping from 6 kilobytes per proof to 5 kilobytes, allowing for more efficient use of bandwidth and storage. Simplifying maintenance and balancing cost and efficiency in recursion. Here is a trade-off. Let's see. Recursive proofs are a cornerstone of advanced cryptographic applications, and the two systems handle them differently. Pluto's Aries delivers smaller circuits, but at a higher CPU cost, which can strain computational resources. BLS flips this trade-off, opting for larger circuits with a lower CPU cost. So after analyzing all these trade-offs, Midnight team decided to switch to a BLS family. Okay, now some concepts regarding smart contracts. For those that are new, we are going through this academy material that Midnight team is providing. They have 8 modules. So far, they have delivered 5 modules. We are right now at the module number 2, and we are going on phases as we go through the sessions. So now, we're gonna study some concepts regarding the smart contracts. What is state variables? What are functions? What are events? And what are modifiers? Let's take a look. State variables, these are like a contract permanent storage. They hold values, numbers, addresses that persist on the blockchain. For example, a contract might have a state variable tracking on an account balance or an owner address. So you can think about this like a database. You actually persist data, but now in a blockchain, we call it an state variable. A function. Functions define the behavior of the contract. They are callable routines that can read or modify state variables and perform computations. We can think about these functions in blockchains as transactions. In Midnight, these functions, we call them circuits because we actually are doing these transactions by sending a proof transaction. For example, in Cardano, we just call them transactions. We perform this function, and if this transaction passes, we are actually gonna modify some state variable. Events. Events are logging mechanisms. Our contract can emit events to record that something happened, which is then stored in the blockchain transaction log. External applications like front-end can listen for events. One question that a lot of people make, or they don't correlate these two concepts, it's regarding events, logs, and state variables. In blockchain, this is actually a doubt that it makes sense because at the end, both are states, but the logs, it's for transaction logs, and the state variables are states at the ledger. So another question would be, okay, what's the difference between a log and a ledger? So let's make an example when we talk about smart contracts. Something that's on the ledger is going to be able to execute a logic on a smart contract. Something that it's on the logs is just for logging purposes. The transactions, for example, in Cardano, we have a metadata. So this metadata, it's part of the log process. It's not within the ledger itself. It's not a state variable. And now modifiers. These are kind of functions. Modifiers are pieces of code that can be applied to functions to change this behavior. These modifiers in Midnight are really powerful, and they allow us to do a specific logic, like, for example, I want this transaction to pass only if the sender has some specific keys. Or, for example, it's the owner of the smart contract. So you can think like a an abstracted function that applies to other functions below that abstraction function. So you want that to pass for other specific logic to actually execute. They give some examples here regarding, for example, only owner. The only owner modifier can check that the caller of a function is the contract owner, enforcing access control. Modifiers help avoid repeating common checks across functions and make the code cleaner. Excellent. Now, before going to the code, I just want to finish with two announcements regarding the one. It's regarding the hackathon. The Midnight team just announced the winners of the last hackathon. The topic was related to tooling, and they made a post. So here in the post, for those that were following the sessions and the hackathon, they know the hackathon had 5 tracks. One regarding to DX libraries, the other one regarding to CLI tools, the other one regarding to dashboards, then integrations and NFTs. The projects that were presented were really broad, diversified. There were I was part of the jury, and the juries were impressed by the amount of projects that actually were presented. Were like 11 projects, and people presented different solutions. It was not just templates. So let's take a look here at the winners, and I'm going to explain what their project was about in a really quick summary. Regarding DX libraries, the first place got the team from the Midnight Forge, Riel, John Santi, and Cyril Lopez. They made a project really nice implemented, and it was the first time that I saw somebody actually running Midnight functions at the server, in the sense of a client asking for something, the server running the circuits, and then responding back to the client. So this is kind of an architecture that pretty much mainly all business applications are going to be implemented in that way. And then on second place was LambDev regarding Wive. They did a template with some really nice contracts, and so they really focus on how to implement contracts on Compact, regarding how to mint token, how to have it was regarding if I remember correctly, it was regarding the how to mint tokens and how to have a reserve. So it was a really nice template. And regarding CLI tools, the first place was for Caleb, and he did a scaffold Midnight. So that's something that Mesh itself, we are pushing really hard for new developers that onboard into Midnight to have kind of a ready template for them to start playing with Midnight. Otherwise, they're going to spend like 1 week trying to have the setup ready, and most of the times they got frustrated and they just leave Midnight. So these scaffold Midnight templates are really helpful, and he presented one of these scaffolds. And then the other team that got second place, they presented a project regarding Node scripts. They were focused on SPOs. So they have scripts to actually implement their logic, and they created a template of a lot of those Node scripts. Regarding dashboard, the first place they presented a project regarding MCP. It was a really nice thing to see. A lot of people nowadays, they are using artificial intelligence to code. No, people know this action as vibe coding, and now there's IDEs that actually implement this, like Windsurf, and what they did is actually create an MCP for this intelligent artificial intelligence client, which was a Windsurf or Cursor, not sure which one they presented, but this client actually was able to talk with the indexer through an MCP. So was a really nice project, and they show how different ways how blockchain can actually interact with artificial intelligence. And then for the other two tracks, integrations, this project from the Helm team was really nice because they implemented something that I don't see that usually. Normally people, they present Dockers, right, for actually running your software, but they went one step ahead. They actually implemented a Kubernetes setup. So if you actually want to have your application scalable, you need to have your Kubernetes. So they created this YAML file and this setup, so you actually can have a scalable application right away. So yeah, really nice project. And on track 5, again, Midnight Forge. Congrats to Midnight Forge. They were the winners for 2 tracks, the DX libraries and the NFT. And they say first place, Midnight Forge again. So they presented this NFT project that actually connects 3 concepts, which is education, collaboration, and compensations. So yeah, they on the tweet they put here this was recorded. So I really recommend you guys to take a look at these presentations. It's really worth taking a look. Okay, and just for closing the ecosystem updates regarding the catalog, Lace team just released Lace Beta. What is this? They did a post. It says, "Step into the future with Midnight on Lace Beta. Lace Beta for Midnight's testnet is here. Experience private shielded transactions, inherits the robust root of trust from Cardano, access cutting-edge Midnight testnet features." For those that are already implemented in Midnight, you know that we have to download the Midnight wallet and use it. Now we're gonna be able to just download it through a web store and use the wallet. So it's a much better user experience. So I'm gonna show you guys how this wallet looks like. It changed a little bit and they added some extra features. So I have here the Lace Beta wallet. I have here as an extension. And we can see here that I have some tokens. I can see that I have some T-Dust. And something that I want to show you that changed from previous wallets, it's that here on settings, we can actually we can choose 2 different networks, the testnet network and the undeployed network. The testnet, we are using actually deploy instances, and undeployed network, it's when we want to host ourselves the instances. And for the testnet network, the something that changed here regarding to the previous wallet is that now we can have a remote proof server. So yeah, this is really nice to have actually, and it's really flexible. Developers they're gonna be able to decide if they want their proof server to be hosted by themselves or their companies, or just use some external services. So now the Lace team, they are hosting a remote proof server. So you can choose if you want local proof server or you want the remote proof server from the Lace team. And for undeployed, it's just your local remote proof server. So yeah, the Lace team, the Midnight team, they just mentioned that this Midnight Beta wallet is going to be supported now in the future, and the previous wallet, they're just gonna they're still gonna maintain that wallet for 1 month, but then the recommended wallet for now on is this Midnight Beta wallet. Okay, so this is all about the ecosystem. Now let's keep learning how to code. So we're gonna open the IDE. Just I want to make sure that I'm not forgetting anything. Yeah, that's it. So now I'm gonna open my IDE. I'm using Windsurf. So last session we finished understanding how to create a provider with a wallet and a Midnight provider, and we understood how a state works in Midnight. So we discussed these states that we have a public and a private state, and the public state we have cswap and kashina. For those that these concepts are not clear, you can go to my past sessions and where we discuss all these concepts. Okay, so let's keep going on the API functions. Now we're gonna learn how to wait on things. So first we're gonna learn this function called wait for sync. We are gonna pass a wallet of type wallet. Again, these types we already learned about all these in the past sessions. In case there's any topic regarding wallet that you don't understand, you can go through my past sessions. So we pass wallet of type wallet, and we are gonna call the wallet method state. This state, it's returning observables. So that's why we're using this library called RxJS. So since the method state, it's returning an observable, we are just gonna wait for the first event. So we call Rx first value from. We pass the observable by writing wallet method state, and then we are gonna use this method of RxJS libraries called pipe, which actually allow us to execute some async functions within the observables. So let's do the following. From the state, I'm gonna throttle a time every 5 seconds, and I'm gonna just log some things regarding the state. I'm gonna log the state sync progress apply gap and the state sync progress the source gap. What is apply gap and what is source gap? Apply gap, it blocks your wallet still needs to process. If this is greater than 0, it means that your wallet is not fully synced. And regarding the source gap, they say blocks the backend still needs to process. If this is greater than 0, it means that the backend is not fully synced. Chain tip minus backend tip. And the apply gap, it's the backend tip last transaction index. So wallets in Midnight works differently. Those that are more they come from Cardano. Wallets in Midnight, we actually have to synchronize the state of the blockchain, because as we learned, everything in the Midnight blockchain are commitments. So we don't know what's inside those commitments. So we have to go through all these commitments and actually decrypt that information using our encryption public key. So that's why we have to, there's a process of synchronizing. So the blockchain through the back end of the wallet, and then the back end of the wallet through our UI. So we have two concepts. The apply gap, they mentioned here, it's the backend tip and last transaction index. So this is the blockchain and the back end of the wallet. If this is synchronized, it's gonna return 0. Otherwise, it's gonna be greater than 0. And the source gap, it's between the back end of the wallet and our UI. Excellent. And then we just log the results. And then we're gonna apply another method called filter of the state, where we are gonna compare if the state sync progress is not undefined, and if the state sync progress is synced. What is this sync? We can see here that we are actually making sure that the apply gap that is here and the source gap are actually 0. So if those two variables are 0, it means our wallet is synced. So this is what this function is doing. Wait for sync. We're making sure our wallet is synchronized. Synchronized from where? From the blockchain to the back end of the wallet, and the back end of the wallet through the UI. Excellent. Now let's study the wait for sync progress. These two functions are pretty much similar, but we can see here that we are calling this wait for sync and this one wait for sync progress. So let's start it. We are passing the wallet of type wallet. And again, we are calling the state of the wallet. And we are gonna use the RxJS library, first value from. We're gonna apply the method pipe to actually execute some async functions within the observable. We're gonna throttle every 5 seconds. We're gonna emit some logs. Again, we are the same logs that we applied up here. And here is the change. We're gonna filter the state, and we are just gonna wait for the sync progress to not be undefined. So if we remember, in this other function, we wait for not to be undefined and actually to be sync. This one, we are not waiting for the wallet to be sync. We're just waiting for the wallet to not be undefined. So that's why we call it wait for sync progress. It means it's doing something, but we acknowledge that that process is ongoing. Okay, this is another function, not regarding waiting a wallet for the process of synchronizing, but actually we're waiting now for funds. So let's start it. Again, we're gonna take the state of the wallet. We're gonna apply the RxJS method, first value from, and we're gonna apply pipe to actually execute functions. We're gonna throttle every 10 seconds. We are gonna log some state variables regarding the apply gap and the source gap. We already studied it. And now let's apply some functions. We're gonna filter the state regarding to sync. So here we did that, right? We wait for the wallet to be sync. So now we are doing the same thing. We are waiting for the wallet to be sync. So if we're waiting for funds, it's obvious that we first have to wait for the wallet to be sync. Otherwise, how do we know if our wallet is funded if it hasn't been synchronized yet? So we wait first for the wallet to be sync, and then I'm just gonna apply a method map where we grab our state and we have balances. If we see what are the methods available on the state, we can see here that we have addresses, available coins, coin public keys. Again, all these concepts, we have already studied them on a previous session. If you're not sure about these concepts, you can go through my past sessions. In this case, we're going to use balances. So for balances, we actually have all the coins of our wallet, but we are only interested on the native tokens. So we have this function provided by the midnight.js libraries from the Ledger library specifically called native token. So this is actually the token type of Dust. So I'm gonna call the native token function, and we just gonna get the type of Dust, and I want to know the balance of Dust within my wallet. And in case there's nothing, I'm just gonna pass 0. So this observable is just gonna emit a value if a balance is greater than 0. Otherwise, it's just gonna keep on waiting. So we can see here, wait for funds. What this function is doing at the end, we're just waiting for our wallet to be synced, and we're waiting to have actually some funds of Dust. If we don't have any funds, we're just gonna keep waiting. Perfect. Now we have this other function, build wallet and wait for funds. We can see that is a really huge function. Until here, from here to here, right? But it's not that big. It's just big because it's iterating through some options. We're gonna take a look at that. So first, let's see what we are actually passing to this function. We are passing the indexer WebSocket, the nodes, and the proof server links from the config files. So again, these config files, we studied at them on a previous session. But let's take a look at the config files to understand where these values are coming from. At the end, all these indexers, node, and proof servers, they are instances being hosted by ourselves or by some provider. And we have to make sure that the wallet implementation knows where those instances are being hosted. In this case, we have different ways to deploy our contracts, and depending on what are the methods were implemented, these instances are gonna be hosted locally or remotely. Okay, so we're passing the instances URLs, and then we're gonna pass the seed of our wallet of type string, and we're gonna pass a file name of type string. What is this file name? Sometimes, and I'm sure maybe some of you guys have already thought about it, is that if the wallet of Midnight is actually syncing, every time that you want to use the wallet, you're gonna have to sync it, right, through the blockchain. And if you start from zero every time, it's gonna take a while every time the users actually want to send a transaction. They're gonna have to wait for the wallet to sync through all the blockchain. So to improve user experience, the wallet implementation has a way to have some kind of how do you call it? Some stopovers, kind of waiting the state of the wallet until certain amount of time. For example, you're using your wallet right now, and then you want to leave your application. The way this file name, what this file name is gonna do is actually, I'm gonna tell the wallet, I want to store my state at this file name, and then when I want to use my application again in the future, I'm gonna say, wallet, restore my wallet, but don't synchronize from zero. Just grab the state that I have stored at this file name, and then start syncing from that point on. So in that way, it's way much faster. We don't have to do everything from zero. And the result of this function, it's gonna be a wallet and resource implementation. This type, wallet and resource, it's actually the type of the wallet implementation. So the purpose of this function is actually to have a wallet. We have seen that here in these other functions, we're actually passing a wallet of type wallet. What we're doing here, it's actually building this implementation of wallet. So we're gonna pass the path of that directory through a process, through a environment variable called sync cache. And then we are declaring this variable, wallet. So, okay, we have this first if. If you don't have this directory path, what it means, okay, I don't want to store my blockchain. I want to just create, the wallet. I just want to create my wallet from zero. So I'm just going to the end of this if. And what I'm gonna do, I'm just gonna build my wallet. So I'm gonna call this wallet builder. Again, this wallet builder, it's coming from a library of Midnight, from the wallet library, wallet builder. So we are just calling this constructor, and we are passing the method build from seed. We can see here that this build from seed is not, they have already changed it. Now it's called build. So if we erase here, we can see here that we have now build. So now it works, right? So we pass build, and then what are the arguments that we have to pass to that function? We're gonna pass the indexer instance that we have, the indexer WebSocket, the proof server, the node, the seed, all these variables, we declare them at the beginning of our functions here. Everything is coming from the config file. So we pass all these instances, and then we already have our wallet. And then we just call start. This method start, it's actually saying the wallet implementation, okay, start syncing my wallet. Perfect. In case we want to store or retrieve some state from the wallet, we're actually going to pass a direct path, and we're going to start executing this code within this if. So we are using just here some node commands for reading and writing into some directory. So we are reading the file name. We pass the file name at the beginning of the function. So we're going to read this file. We're going to store it on the serialized stream. They're going to, and just going to call this a stream to string from this fs read stream. This stream to string is a function that was declared here at the bottom, where actually we're just passing a stream from nodes and we are getting a string, right? Through this implementation. So here we have the string, we have our state of our wallet. So now we are gonna call this serialized stream. On finish, we are gonna close, and we are gonna now build our wallet with the state. How do we do that? If we remember here, when we build our wallet without a state, we are actually passing the get cswap network ID. This is telling the wallet implementation, I want to use this ID of the network. But if we have a state, we don't need to pass this anymore. We actually pass the state. So if we look up here, for building this wallet now that we have a state, sorry, where is that? It's okay. Here we are applying another if. If that state it's actually from another chain, so this is just a security measure. If that state, for some reason, the developer it's grabbing a state that it's not from the actually chain that the wallet is looking at, it's just gonna fail. And what the implementation is doing, okay, since you don't have the correct state, I'm just gonna build a wallet from zero. So we're just passing the seed and get cswap network ID. And we are starting to synchronize the wallet. If the wallet was okay, then what we're gonna do, we are just gonna wait for sync. This function was, we took a look at the beginning, wait for sync, where is that? Here, wait for sync. We already know what that function does, right? We are passing just a wallet implementation and we are just waiting for that wallet to be sync. So now we are just using that function again and we're just waiting for that wallet to be sync. If it's sync, we are just returning the wallet. That's it. If it's not, we're just gonna log, and when the process is done, we're gonna build the wallet again with this process, with the constructor, and we are starting to synchronize. So we can see here how this process works, right? It's just a matter of iteration regarding the state of our wallet and regarding if the state it's correlated to the actual network that we are connected, and the return it's actually a wallet implementation and it starts on syncing. And at the end we have this part of the code within the same function that we are studying that applies for all the wallets that happen during this iteration, during this if else. So what are we gonna do? We're just gonna grab the state of the wallet. We're gonna wait for the first value, and then we're gonna see the balance of our wallet regarding Dust native token. We already know what this function does, and we are gonna wait for funds. And once we have funds, this function again we started before. We're waiting for our wallet to have at least one Dust, and once it has some Dust, what's this function gonna do is just gonna return wallet. So this function it's building our wallet either with a state stored by ourselves or from zero, And then we're waiting for that wallet to be synced. We're waiting for that wallet to actually have funds. And then we are returning the wallet. Excellent. So, well, that regarding the code, we already know how to implement a wallet, how to run different functions. So now we are really close to, there are some other functions that are missing that we're gonna go through them in the next session regarding random bytes, build fresh wallet, configure providers, and save state. And after those APIs functions are done, we are ready to go through the CLI part. So in this part, we are actually learning how to use those API functions that we learned to actually run our first smart contract, how to actually create a transaction, how to sign the transaction, how to submit the transaction, how to attach a proof, and how to receive a confirmation from the node and the indexer. Okay, that was a lot of information. That's why we are doing these sessions now once a week during 1 hour. So we have more time to actually show you guys the code and the ecosystem updates, and to actually have some chats regarding questions. So now we're going to start the process of questions. I'm gonna allow requests from everybody. If you want to jump into the stage, you're welcome to do that. Just raise your hand, or you can write your questions here. Let's see if anybody has any questions. Formal verification for compact. That was wipe. Yeah, exact. Now remember one of these projects. Really nice. Okay, now thank you, Lam, for confirming. Wipe. He mentioned the regarding. Let me open here again the regarding the hackathons. This project, the wipe, actually was regarding the formal verification. So it was a really nice project as well. He actually he created the foundations of how actually to implement this formal verification with the compact. And he actually used a framework different from the ones that I'm used to here within Cardano. And the owner of the project mentioned that this framework, it's more kind of has a better developer experience. So maintainability, upgradability, it's much easier to do. Okay, John has some question here. Good question. So for any local environment deployment Docker, you would use an undeploy selector in Lace. Nice, it's auto-generated fault holders and jet decays one-on-one to avoid being a star value. Theoretically, one could set up a dApp that is fully funded with Dust for the customers for decentralized apps that are auto-funded by developers. Is there some mechanism to be sure your dApp always has enough Dust to service customer users so they are not even aware they are interacting with blockchain? What is a good efficient amount of time for waiting for sync? Okay, John. Really, really nice questions there. So the first one, it's you're mentioning regarding the Dust, right? So what happens is that let's put an example of night. Let's imagine if a midnight blockchain uses nights to actually execute transaction. You have to spend your nights. The dApp developer, the owner of the dApp, they actually need to hold Dust, to hold nights, and they spend those nights. But since night, it's not related to, for example, dollars or another currency. If it goes up, the transaction cost is gonna go up. And your customers, for example, you can offer them, okay, you're gonna pay some amount of nights. But nowadays, businesses, they want to know how much it's going to cost for them to actually use your application in the next 1 year, 2 years, because they forecast their costs, right? So you cannot use night because it's volatile. You cannot say, okay, night is going to have that value for the next 1 year. You don't have control for that. So you need some means to actually allow your users to execute transactions with a more stable cryptocurrency. So in this case, what the Midnight team did with the tokenomics is having the night and the dust. And dust, night is generating dust at a specific rate. So in that way, at time 0, you buy some night that is going to generate some dust that you know as a business owner that you're going to need that amount of dust per month for your users to actually execute transactions. So you just buy nights one time at time 0. And then you don't worry about dust or night going up in value because it doesn't matter. What you care about is the generation rate, right? If you start having more users, okay, then you're going to have to buy more nights to actually generate more dust. But let's say if you have a constant amount of users, the amount of night that you bought at the beginning is just going to generate that amount of dust. So you don't worry about these fluctuations of the price. And regarding to your other questions, John, is there some mechanisms to be sure your DApp always has enough dust to service customers? If you depend on somebody else, something nice about Night is that people are going to be able to select the battery pack, the shielded address. The way I call them, it's shielded battery pack, because the Night holders are going to be able to choose what shielded addresses they want to select to actually generate dust. So for example, John, if you hold Night and you want to help some dApp developer or platform, you can select that shielded address to generate dust on that address. Of course, the dApp developer and the owner are not going to be able to have a guarantee, 100% guarantee that delegation is going to last forever, right? Because you at any time can delegate to somebody else, right? But well, during a small amount of time, okay, the developer can have some leverage from dust delegation, and then plan themselves to actually buy Night to actually generate dust. Okay. Andrew has here another question. Do we know the actual rate at which a given amount of Night emits dust? No, Andrew. We don't have that. That information yet. It's they're gonna announce it later on. But what we know, it's that the generation rate, it's gonna be the same as the decaying rate. So the rate that your dust are gonna be generated from Nights, the same proportion is gonna happen if you stop using the dust. It's gonna decay at the same proportion. Yeah, but the generation rate, it hasn't been announced yet. The question: can you delegate to multiple addresses at the same time? If it's one-to-one, wouldn't that make it a store of energy? Yeah, well, the multiple addresses, that's not sure if it's gonna be possible. I haven't seen that information yet. Not sure about that, John. I think it's just one address of Night to one of one shielded address to one shielded address. But in any case, what you can do if that feature is not allowed or possible or implemented, it's you can have different addresses and select different shielded addresses if you want to. The same thing as we do like in delegations. Okay. Leaf has another question here. So if dust is used for transaction fees, but can be transmitted to other wallets and or decays, how are validators sufficiently incentivized to participate in block creation? How are they covering compute costs? Okay, really nice question, Leaf. What happened here is that we have these two tokens. We have night tokens and we have dust tokens, right? Dust is just going to be for covering transaction costs. And block producers, they are going to earn rewards from the night coin emission. Not sure if you're aware of how Cardano works, but it's pretty much the same. Midnight, they want to have a treasury and they want to have reserves. From those reserves, these compensations are going to block producers, right? So the way other blockchains work, it's compensations to block producers is coming from this reserve plus transaction fees. In case of Midnight, the compensation of block producers is just coming from the reserve. There is no transaction fees. And a good question would be, okay, but that's not sustainable. What happens when that reserves deplete and there's no more incentives for block producers? So that's where this concept comes into play. Let me open here. That's why I mentioned you guys that this concept is really powerful and it's gonna allow a lot of use cases, even for the treasury and even for the treasury and the reserves of Midnight. So let me see if I can find the Charles post. They mention three things: the tissue, hybrid apps, the token model, and the capacity exchange. So this capacity exchange, we haven't mentioned that too much, but what it actually does, is this. People, they need dust to actually execute transactions, right? Those ones that have night generate dust for actually executing transactions. But let's imagine if you have a way to actually delegate your dust from your nights, and you have a revenue from that. Because right now, you just generate dust, and you're gonna have to use it. Otherwise, it decays. So you don't earn nothing from it. So this capacity exchange, there are different mechanisms where people are gonna be able to actually rent the night, the dust generation. So let's say, for example, John has some nights, and I'm a dApp developer, and I need dust for my application. And I'm like, John, can you delegate your night and your dust generation to this shielded address? And I'm gonna pay you X amount of dollars, for example, for that delegation. So in that case, John is gonna have a revenue from their nights without losing possession of the nights. They're just giving me that rent. So this is an off-chain mechanism. We need to trust each other, but as in the white paper mentioned, there are gonna be mechanisms for off-chain and on-chain implementations. And this on-chain implementation, since it's gonna be an on-chain coming from the ledger itself, people that holds night are gonna be able to tell to the treasury or reserve of Midnight, I have these nights. I want you to actually generate some money from these nights. So they're gonna create these capacity exchanges, and part of the revenue they're gonna pass to the night holders, and the other part is gonna be sent to the treasury. So that's another way to fund the reserves and the treasury itself. Okay. Creation, how are they coming? Okay, John has another question. I love that it is one-on-one and then it's stable. Predictable dust, energy based on night holdings. Yeah, leave. Block rewards, ignite black transaction fees. Yeah. So these mechanics are really gonna be transformative, and it's gonna open really nice dApps and implementations regarding this capacity exchange. That's why Charles mentioned these three things, right? Dual token model, capacity exchange, and hybrid apps. Well, Not sure if there's any other question or somebody wants to jump into the stage. John is typing here something. Let's wait for John. And Leaf mentioned here. Nice. So to start, all the validators are Cardano stake pool operators that run some sort of midnight protocol block producers logic alone. I didn't understand. Okay. It's a question. Not sure if it's a question. So they're all the validators are stake pool operators that didn't understand the question, Leaf. Sorry. Yeah, John, it's sorry. I don't really understand who the validators are, how midnight blocks are produced. Okay, Leaf, the way it's gonna work, and this is another Midnight is really connected to Cardano. The SPOs, the Cardano block producers, are gonna be running two nodes. One node of Cardano and the other node of Midnight. So they're gonna be running those instances in parallel, the same block producer, and the node at Midnight blockchain, they are gonna actually produce the blocks, but who's gonna decide which one of those node producers are actually gonna create the block? It's Cardano consensus. So this consensus is gonna come from the stake that those pools have from Edda. Not sure if it was clear how midnight blocks are. Yeah. And this is gonna open a lot of opportunities for SPOs, right, Liv? Right now, there's a framework called Partner Chain Framework, where Midnight it's the first partner chain of Cardano, but in the future we're gonna have many other partner chains, and the Cardano nodes SPOs, they're gonna select which partner chain they want to support. And the delegators themselves as well, right? Which SPOs they want to support, depending on what are the partner chain nodes they are running in parallel from the Cardano nodes. So there's an extra revenue. Now with Midnight, the Edda delegators and SPOs, they are gonna earn Edda and Midnight night at the same time. And in the future, as more partner chains, imagine an SPO running, let's say, 20 partner chains. So you're going to have Edda plus 20 other blockchain tokens. John is saying, to be a Midnight block producer, you must also be a Cardano block producer. Yeah, that's the condition. You need to be first a Cardano SPO to actually be a Midnight producer. On Midnight Discord, there is a section for any block producers. So if you're interested on becoming a Midnight block producer, you can start on Midnight Discord. And there's a section for that. I mean, where all the Cardano SPOs are joining and asking how we can start implementing and testing being a Midnight block producer. It's really straightforward. It's really easy to. The difficult part to actually become a Midnight block producer is to actually have some delegation as a Cardano SPO. If you're already a Cardano SPO, to become a Midnight producer, it's really easy in the sense of software implementation. Of course, you're gonna need to increment your hardware. You're gonna need more CPU, RAM power. Yeah. Well, let's wait here for the last question of Leaf. Sounds really cool. I think I need to read up on the partner chains framework. That might be where I'm missing knowledge. Steve is the Midnight Dev who's running that. Yeah, Leaf. I mean, you can go to the Midnight Discord, and then you can ask all your questions here. The partner chains itself, it's if you want to be a Midnight producer, you just go to Discord and read how to actually implement. If you want to understand how all this works regarding the tissue and how other blockchains in the future are going to be able to give support to Midnight as well, yeah, for sure, reading the partner chain framework, it's going to be really nice for you to understand how all these pieces connect each other. It's actually really, really complex. It's a piece of marvel, actually. Steve has a blog producer set up to Teravita. Yeah. Okay, guys. So, yep. This is all for this session. Next session, we're going to finish the API functions. And the main idea, as I mentioned before, it's the scope of this section is actually to be a proficient dApp developer. We're going to learn how to write end-to-end dApp applications and actually understand the business side. That's why we are going through some ecosystem updates to actually know what are the different providers that we can actually use, what are the different business needs that are requiring some features that Midnight can offer. So yeah, that's the main idea of the sessions. And all these sessions are gonna be recorded on YouTube. And the reason that I'm doing live during this time, it's for actually people to jump in and ask me questions. And yeah, that's the main idea. And the idea is just to go. I'm gonna be doing these sessions through this year, so we're gonna have a lot of time, and there's a lot of topics to cover, and we are just scratching the surface. Much more to come. So see you next session, and thank you all for coming. See you all next week. Bye bye.